Welcome to Click Academic. This is a series of videos on set and number system. Today's lesson is based on mathematical induction. Mathematical induction is one of the principles that we normally use in order to show or to test the validity of a statement or a formula given to you. Is it mathematical formula? Is it physics formula? Any mathematical derivation, there must be a validity or validation of that. So to test the validation, we use a mathematical induction. Here are the principles. Step 1, to show that the statement is true for n equals to 1, for n equals to 2, for n equals to 3. Once is satisfied, the left hand side equals to the right hand side, so meaning that the step 1 is complete. Then step 2. Step 2, to assume that the statement is true, that is valid for n equals to k. That is, we are assuming that since it's satisfied for n equals to 1, n equals to 10, we should assume for n equals to k. After assumption, then the next step is step 3. To show, meaning prove, that the statement is true for n equals to k plus 1. After we have assumed that n equals to k, then we should what? Test it for n equals to k. That if it's satisfied, so that what? Formula is a valid formula. So now, here I have one example. You see that example 1, prove by mathematical induction that a plus open bracket a plus d closing bracket plus open bracket a plus 2d closing bracket plus open bracket a plus 3d closing bracket. There are a lot of numbers that were in this. So to make it short and go to the last term, then we have what? N minus 1d, which is show the what? The last term. This, the whole of it is equal to n all about 2 open bracket 2a plus open bracket n minus 1 closing bracket d closing bracket. So now we are going to what? Test the validity of this formula. Is this formula is a right, standard, accurate or not? So we'll see that. So now let's apply the principle of mathematical induction to solve this formula. As we say solution, let's say step 1. Step 1, we say to what? To show that the statement is what? Is true for n equals to 1, 2, continuously. So if n equals to 1, so now look at this. These are the given statement given to us. Now we are going to take the first term of our left hand side. Here in our left hand side, the first term here is what? Is a. Therefore, for n equals to 1, in our left hand side is what? Is equals to a. Then our right hand side, which is right hand side, we have what? Anywhere we see n, we are going to put 1. This is 1 over 2 into 2a plus 1 minus 1d. That's it, 1 minus 1d. Now, if you look at this, to be 1 over, this is 2 plus this time minus this is 0. And anything times 0 is 0. Therefore, it's this. Now, this, the whole of it, it will be what? A. Therefore, the left hand side is equals to what? Is equals to the right hand side, which is equals to a. Then if for n equals to 2, the left hand side we what? Now we are going to consider the first two terms, this and this, which is what? A plus open bracket a plus d closing bracket. This should be what? A plus d. This should be what? 2a plus d. Then our right hand side, to test for the validity, then we have what? 2 divided by 2 into 2a plus what? 2 minus 1d. This is the same thing as 1, which is no need for writing. Then we have what? 2a plus 2 minus this is just d. Now if you look at this and this, they are the same. Therefore, the left hand side is equals to what? The right hand side, which is what? Which is 2a plus d. So therefore, step 1 is complete. So we now move to the step 2. Step 2 said that what? We should assume. To assume that the statement is true for n equals to k. That's where we are going to assume, make assumption. So now if you look at this statement, we are going to say, okay, a plus d into a plus 2d plus a plus 3d plus into what? a plus open bracket k minus 1d is equal to k divided by 2 into what? 2k plus k minus 1d. Now if you look at this, you see that from here we have n, so we see that for n equals to k, so we are replacing k wherever n it is. So therefore the step what? Step 2 is complete. Now step 3. Step 3, we are to prove that the statement is true for n is equals to k plus 1. So therefore here we are going to see what? In the statement given to us here, we are expecting to see what? K plus 1. So now recall that a plus what? A plus d plus what? A plus 2d plus what? A plus 3d plus into k minus 1d plus. After this, since we are having k plus 1 term, so we have expecting to have the next term. So therefore here should be what? K plus what? K plus 1 minus 1d. Right? So now if you look at this, the whole of this is equal to this. So therefore, and this is equal to this. So we can remove this and substitute with this since they are equal. So we have k all about 2 into what? 2a plus open bracket k minus 1d, then plus. This statement is what? A plus, this is plus 1 minus 1, which is 0. Therefore k times d, which is kd. Now let's continue. Now take the LCM. You have what? 2 into this is just k into 2a plus k minus d, all closing bracket. Then this is what? 2 into k plus kd. Right? Therefore this is times this. We have k into 2a plus what? Kd minus d minus this time this is just 2a plus what? 2kd all over what? 2. Then this time this we have 2ak plus what? K square d minus what? Kd plus what? 2a plus what? 2kd all divided by 2. Then this is the same thing as, now this will have k square d. Now this is the same thing as what? Now this and this, you see that there's minus 1 plus 2, which is same as plus what? Kd. Then this and this, they are almost equal. Then we have what? 2ak plus 2a. Now we are collecting the like term. Then this is same thing as equal to, something is common, kd is common. Let's factor kd out. We have k. If you factor kd here, you have k. If you factor kd here, you have 1. Right? Then this statement, we have 2a as common, which is 2a into what? K plus 1 as common. Now, if you look at this, we have common factor. K plus 1 is a common factor. We should factor it out. We have k plus 1 all divided by 2 into kd plus what? 2a. Now, this is statement. So now, this can be written like this. K plus 1 all over 2 into 2a plus what? Kd. Remember that plus is commutative. You can twist it. So here, in mathematics, if I said minus 1 plus 1, it's like I did nothing. So plus this, I can say, okay, k is plus 1 minus 1d. Now, if you look at this, plus 1 minus 1 is 0. So I did not do anything. So this is something as what? K plus 1 all squared, all divided by 2. K, this is the same thing as open bracket k plus 1 minus 1d as required. This is the proof. Now, if you take this and you compare with the given equation that we are given, that says that what? N divided by 2 into 2a plus what? N minus 1d. Now, you see n here is what? K plus 1. N here is what? K plus 1. So that's just the proof. Then this is the end of our today's lesson. To meet in next lesson.